The Hudson River flows from Lake Tier of the Clouds in the Adirondack Mountains down to the New York Harbor into the Atlantic Ocean. This river has been seen by millions of people and is an essential body of water for the surrounding communities. However, when discussing the clarity of the river with everyday people, there seems to be a negative connotation. It's a common misconception that the Hudson River is a very dirty and polluted river, just by the way it looks. So, how dirty do you think the river is? If you stick around, you might find that the river isn't as dirty as you might have thought. The color of the river is called its turbidity. Turbidity is the opacity or the cloudiness of the river and is caused by a number of factors, including salinity, precipitation, sediment, organic matter, and tides. However, we'll discuss each of these parameters' impact on turbidity in the next section. The amount of pollution in the Hudson may result in less opaque water. For example, when old factories would dump waste chemicals as a mode of dilution, or, as we see today, when sewage is released into the Hudson because of combined sewer overflows. This will inevitably change its color. The cloudiness of the water doesn't necessarily mean that it's dirty. Sediments, rocks, organic matter, such as leaves, branches, decomposed organisms, are materials that make bodies of water naturally turbid. In fact, when compared to other water sources using a Secchi disk, the Hudson River isn't extremely polluted. However, depending on what point you are on the river, the turbidity will vary.
So, what impacts turbidity? Salinity is the amount of salt in the water in parts per thousand. When salinity increases, so does density. As the salty water threads its way up the Hudson, the turbulence of fresh and salt water mixing decreases the clarity. Precipitation is the amount of rainfall or snow. When precipitation increases, it picks up sediment from the land, bringing it into the Hudson. The currents mix it with pigmented sediment, causing the brownish color you see. Tides are the push and pull of the river currents, and again affect sediment which mixes with the water to create a pigmented look. Organic matter includes all the plants and animals in the river. These will then biodegrade. The pigment from these organisms mixes with the Hudson to increase turbidity.
Now that you have a general sense of what turbidity is, let's apply it to a graph. We are going to look at turbidity from the Pierre sites using graphs that we got from the Hudson River Environmental Conditions Observing System website. I don't know how to pronounce the abbreviation for it. I'm sorry. This graph shows the relationship between turbidity and precipitation over the course of 5 days. As the tide moves up and down the Hudson River, it carries sediments along with it, making the river turbid. In the graph, you can see that there is an increase in precipitation. However, as you can see, the turbidity is still low. That's because after a rain event, there is a lag because all the rain will take time to go down the watershed into the Hudson, which is why the next day you will see an increase of turbidity since the tides have finally moved through the site and unsettled all the sediments from the bottom of the river. Afterwards, you can start to see the turbidity decrease, which means that the sediments are beginning to settle again, which should make the water a bit more clearer, but it'll still stay a bit turbid. Based on this, you can tell that the rain event was a driving force for the rapid increase in turbidity. When you look at these types of graphs, you should always keep in mind what the weather was like because it can greatly affect your data.